The differential forms of the fundamental laws. Tutorial number 7. The velocity of air in a pipe is measured at 0.5 meters apart to be 137, 147 and 159 meter per second respectively. At the middle point, the temperature is 5 degrees Celsius and the pressure is 124 kilopascal absolute. Find d rho over dx at the middle point of this steady and uniform flows. So you could imagine, as a previous question, we have a nozzle or a pipe like this, and then we have a 3-point ABC, and the velocity at this point is mentioned as 137, 147 and 159 meter per second. So in this question, we use air as the fluid inside this nozzle. So might be we cannot say this air is incompressible. Usually, if we use air in the fluid, we must assume that it sometimes can be compressible flow. So this is our continuity equation. We have all of these terms. We make assumption. So it is a steady flow. So we take d over dt is equal to 0. And it is also uniform. So we take del over del y equal del over del z is equal to 0. And means that everything here can be simplified. So we could simplify our Navier-Stokes equation as this. 0 equal u del rho over del x plus rho del u over del x. So in this term, we cannot neglect the value of density because we are using an air. So air it has possibility to be compressed. So for the middle point, we know that the velocity is equal to 147 meter per second. So we need to calculate the density at the middle point. We know that rho is equal to P over RT. The pressure is given in the question as 124 kilopascal absolute. And R here is 287, the gas constant. For an air, we could use 287, and temperature is 5 degrees Celsius, so we need to change into Kelvin. So we plus with 273. So we calculate this value, we could get that the density at the middle point is equal to 1.554 kilogram per meter cube. So we could calculate the value of del u over del x by solving this one. So we have I have already described about this in previous tutorial. So we have del u over del x equal 220 meter per second meter. So we have u del rho over del x is equal to minus rho del u over del x. So this term is actually come from this term. So we bring the value of this one to the left side. So we have minus sign like this. So we substitute the value of rho that we calculate here. It is 1.554. So we have negative here. And we have du dx 220. So we could get the value del rho over del x. So by divide this value with u here. So u is already calculated here is 147. So we divide it with 147 here. So we get del rho over del x is equal to 2.3257 kilogram per meter by the power of 4.